We'll now create a game where we can burst bubbles with our hands. This game is based on a similar project available on the Scratch website, and it combines cloning with the use of the camera. Let's try it out. Fun, right? Let's build this game. The game's interface is very simple. There are many bubbles over our own image, which is captured by the camera. All these bubbles look alike and they have the same behavior, so we can simply define a single sprite for a bubble and clone it. Let's develop the interface. In a new project, we'll delete the cat and draw the bubble ourselves, like this. At the beginning of the game, the camera is turned on, and then bubbles are created continuously with a short pause between each bubble generation. Let's code this. We'll introduce a green flag block, followed by a block for turning the video on. We can also set the video transparency as desired, say at 50%. Next, we'll introduce a forever block, inside which we'll put some code for creating the bubble clones and waiting for a short time. We'll also make the bubble sprite disappear at the beginning of this program, just like we discussed in the example for hunting ghosts. The behavior of each bubble has two main parts, its initialization and its movement upwards. The initialization involves three aspects: positioning the bubble on the stage and setting its size and direction. The floating procedure includes three aspects: the upwards movement of the bubble, bursting the bubble by hand, and its behavior when it reaches the edge of the stage. Okay, now that we have a better idea about the behavior of the clones, let's implement it. We'll first specify that when a new bubble clone is created, it will first be initialized and then float. Let's first specify the initialize procedure. We want to place the bubble somewhere on the bottom of the screen, making sure that the different clones are placed on different spots, which cannot be easily guessed. To do this, we'll set the y-coordinate to be -150, while the x-coordinate will be randomly chosen from the range -200 to 100. The initialization also involves setting the size of the bubble clone, which can again be randomly chosen, and setting its direction so that it points upwards, which will be handy for the subsequent floating behavior. Finally, we'll introduce a show block. Now let's have a look at the floating procedure. Following our pseudocode, we'll introduce a forever block, and inside this infinite loop, we'll put a move block. To make this movement cuter, we'll specify that the bubbles turn slightly. Once it is detected that there's movement over the bubble, it will burst, which involves making a pop sound and deleting this clone. If at any point the bubble touches the edge of the screen, it will also be deleted, but this time without making a sound. Let's test it. We now have a bubble game. Cool, right? You can extend this further to include color effects when you burst a bubble, or to keep track of the bubbles that you pop. But before you go ahead to extend this game, let's have another look at our code. We can see different scripts for the bubble. Each script carries out a particular task, such as specify the bubble clone behavior, initialize each bubble, or get the bubble to go up. We can characterize this code as modular, which means that we have separate components for different parts of our program. These components are dedicated to a particular functionality of the program, and they are combined in a way that gives us the overall program behavior. Modularity is a very good software property, as it makes it easier to reuse our code, change it, and maintain it, as well as understand it. We encourage you to build programs that are modular, and defining procedures can definitely help you do that. Have a think about the programs that you've developed so far. Can you modify them to distinguish between different components? Have a go.